So starting with the next topic, introduction to large language models. So when we discuss about large language models, these are the outcomes of trained transformer architecture network. So large because it is trained on large corpus of words or large corpus of text. How large? Everything that is available on the internet that has been used to train these models by these companies. And they are the language models. They are capable of generating language, hence large language models. So large language models are advanced AI system trained on massive text corpora, enabling sophisticated capabilities such as text generation, language translation, and question answering. They are built on deep learning architectures like Transformer, which allow them to understand complex linguistic patterns and context. LLMs also support multimodal inputs, meaning they can process and generate content across various data types, such as text and images. Furthermore, these models can be fine-tuned for specialized tasks, making them highly adaptable across industries and applications. Key features for large language model: massive training scale. As suggested, it has massive training scale, trained on trillions of words. LLMs grasp nuanced meaning, context, and intent with remarkable depth. Transformer intelligence. Powered by transformer architecture, they model complex pattern and long-range dependencies in language. Beyond text, advanced LLMs process multimodal data. That is, they can do text, images, audio, making them versatile across creative and analytic tasks. Task versatility. From legal analysis to creative writing, fine-tuned or prompt-engineered LLMs adapt seamlessly to specialized domains and objectives. So, large language models and their use cases. First one, general purpose large language models. The one that we use daily, most commonly used, and the market leader currently, GPT-4. GPT-4o, we have so many versions. So, LLMs and their use cases. So, when we discuss large language models are used for many purposes. It starts from writing essays, completing projects for school students, and it goes until creating research papers for doctorate people, creating documents, SOPs for professionals. They are used for many use cases. So the ones that we generally use, where we have conversations with these models, check for questions, check for facts and summaries, they are the general purpose large language models. Commonly GPT-4, Gemini 1.5, Claude, DeepSeek, and more. Now, when we discuss these models are based for any models. Now, when we train these models, as discussed, they are trained on large corpus of text. So, when we are training a large language model on large corpus of text, it will definitely require good amount of computing along with huge amount of training time as well. So when we use these models, when these models are created, they are created for general purpose. So to use them for specific task, companies come up with special large language models. How they do it? They make use of these base models and they fine tune it for their own use case. That is, once these models are trained on a specific use case, GPT knows rules for countries. Rules for countries. That is, what is the law for a specific country? Because that is general information. Now let's say this same GPT, that is generative pre-trained transformer. This same GPT is supposed to be used for an MNC in healthcare. So rules for that healthcare, is going to be different. GPT model knows how to communicate. It is really good with that, but it does not know the rules for this healthcare domain. So what is being done? either these models are prompt, engineered, or fine-tuned. Because training these models from scratch is an expensive task. We have to spend billions and billions of dollars to train these things. Along with that, it is going to take a high training time as well. So to overcome that thing, these general purpose LLMs that are created by these tech giants, they are reused by different companies to create task-specific large language models. For example, People GPT Jules Box, it is specifically built for HR use cases like resume screening, candidate outreach, and policy. Product GPT, that is used for writing PRDs, user stories, feature specs, and analyzing user feedbacks. Salesforce Einstein GPT, that is tailored for sales and service workflows like lead generation, CRM updates, and support replies. Finance LLM like FinTech, designed for financial tasks including report generation, forecasting, and risk analysis. So here we discussed what are these general purpose LLMs, how are they used, and how are they used for specific tasks as well. Next, when we look at these transformer models, like discussed in the previous slide as well, how is it work and how the transformer encoder decoder is going to give us an output. That architecture was discussed for sequence to sequence. Architecture was discussed for sequence to sequence transformers. There are many different kinds of transformers available. We use it depending on the use case. So the first one we have here is auto-regressive models. So they generate content sequentially predicting each token using the context of the preceding token. This method excels in applications such as storytelling, programming assistance, and multilingual translation. Sequence to sequence models, the one that we commonly use. These are really good for text translation, answering questions, summarizing text, having a conversational bot. And then masked language models like MLM. These models trains by filling in missing words within sentence, enabling a deeper grasp of context and word association. They commonly serve as foundational models for fine-tuning in various NLP tasks. Example, bidirectional representation transformer or Roberta. So when we discuss transformer models, we have different type of transformer models. Auto-regressive one, the one predicting the next word in the sentence. Sequence to sequence model, the one that are able to have a conversation with us like normal. And MLM models or masked language models, these models are usually used as a starting point to training these other kind of models for us. Then encoder-only model. Encoder-only models utilize just the transformer's encoder to extract meaningful representation from the text. They are primarily employed in tasks like sentiment analysis, name entity recognition, and document classification. Then we have WIT, that is vision transformer, speech transformer, and many more. So here we discussed what are LLMs and what are the different kind of LLMs. Now, moving on to the next topic, how do we get these LLMs? Because there are definitely many LLMs available. So how do we get to these large language models? So to get all these large language models, we have a website called as Hugging Face. So Hugging Face is a company and open source platform specializing in NLP, computer vision, that is Gen AI tools, offering a comprehensive ecosystem of tools and resources for developers, researchers, and students. Great thing about Hugging Face, even that I like, is it is open source hub for AI models, not just for NLP, but for all these things. For even computer vision, for natural language, for multimodal, you want We want GPTs, Gemini, or we want Googles, or we want Facebooks. So when we discuss Hugging Face, so when we want a model like Gemini, or we want a model coming from FB Meta, all the models are available over here for free. So, and later we'll also discuss how can we use that and use it for a specific use case. So let's make use of this Hugging Face library and build our own models here.